VDC, then again minus 2 VDC connected across the load. Again current flows through the S4 switch and again returned back to the supply. Next again S1, S2 off condition, and again S3, S5 off conditions, then S4 on. So S1 is off and S2 is off, S3 on. Then S4 on, S3 on, then remaining switches are off condition, then you will get as a 3 VDC. So S1 off, S2 off, S3 on, then S4 on, S5 is off condition. So VDC, 3 VDC is connected across the load. So totally, so you have a positive VDC and then 2 VDC, 3 VDC, then again 0 level and minus VDC, then minus 2 VDC and minus 3 VDC. Then your level is 7 level. So this is the working of the this proposed multi-level inverters, right? So we have a different configuration of multi-level inverter. We need to reduce the switches. Okay, so now based on the reduction of the switches, they framed as a reduced switches based MLI topology. Here there are different configurations are there. By using a 5 switches, we are going to obtain for the 7 level output of MLI. This is the one of the topology. So in this topology, we need to generate for the carrier signal. So total number of carrier signal here we are going to use for the 6 carrier signals. Like positive group we are going to use for a 3 carrier signal. For negative group, let us take for the positive level, we are going to use for a 3 carrier signal. Carrier signal means a triangular signal. Again in the negative group, again we are going to take it as a 3 more carrier signal. In the 0 level, we are going to use for the constant block. That is also act as a one carrier signals, right? So we are going to obtain for 7 level. So that's why we are going to use for a 7 carrier signal. But in positive group, we are going to use for triangular 3 carrier, and negative group we are going to use for a 3 more carrier signal. For a constant VDC, 0 level, we are going to use for the constant block. So this is the MATLAB symboling diagram. How do you generate the PWM pulses for the proposed multi-level inverter? So here you have a sine waveform. So actually you know very well about how do you control the inverter output voltage by varying the modulation index. Modulation index means the ratio of the reference signal to carrier signal. So by changing the modulation index, we are going to control our output voltage of the inverters. Normally, what is the control parameter for inverter is modulation index. For a chopper means like let us take for a DC-DC converter. Yesterday we discussed about some topology. Shepard-Taylor converters, right? So in the Shepard-Taylor converter, we are changing for duty cycle. So duty cycle is a control parameter. So by changing the duty cycle, we are able to control our output voltage. Suppose for the rectifier, so we can change our firing angle. Suppose for a DL converter also, we can change the firing angle. So it will be act as a rectifier for 0 to 90 degree firing angle. Suppose it will be act as an inverter means we can change for firing angle 90 to 180 degree. So now coming to the inverter, so the control parameter is here, modulation index, the ratio of the reference to carrier signal. Here the reference we are taken as a sine waveform. Okay, so the carrier signal is always a triangular signal. So that ratio we are represented as a modulation index. So modulation index also varies from 0 to 1. If you change the modulation index, it will also reflect your output voltage. We are also going to control our output voltage, right? So that's why here you have a reference value. Okay, you can change only the reference signal. In the sinusoidal sine waveform, you have an amplitude. You can change the amplitude value 0.8 or 0.6 and 0.4. You can vary the reference signal. Your output voltage also controlled. But the carrier signal is fixed. You don't change for your carrier signal. It is a fixed value. Okay, so carrier signal is always a triangular signal. Okay, so how do you form this triangular signal is, let us take for the okay, so let us take for the start from 0. Okay, start from 0. So the maximum value we are going to take it as a 1 maximum value. Similarly in the negative also we are going to take it as a -1. The y-axis magnitude we are going to take it as a maximum value 1 and negative is a -1. Now first triangle I have to start from the 0 to up to, let us take for the, you have to, so maybe you can take for 0.3. So within the range you have to fix. Let us take for the magnitude of the first triangle is 0.3. So within the 1 I have to frame for the 3 triangles. Okay, so now start from the, so the starting value 0, then maximum value is 0.3, ending value is also 0. Again the size, it will be repeated. Okay, next again we can go for the next triangle. Starting value, this is for 0.3, this is for a 0.3. Next triangle, starting value is 0.3, then maximum value is 0.6. This is for a 0.6. Let us take for, this is for a 0.6. So starting value 0.3, the next value 0.6, again return back to 0.3. So now we are going to form the triangle like this. Okay. Next triangle, again the starting value is 0.6, then let us take for the ending value is 0.9. So you just increase the 0.3. So this is for 0.3. So 0.9 now. Again starting value 0.6, then next value is 0.9, again return back to 0.6, right? So now we are going to do like this, right? The same thing we are repeated in the negative group also, but it is in a minus. So it is in minus, this is for minus 0.3, minus 0.3. So again start from like this. So this is minus 0.6. So then again, next again another one, starting value 0.6 and ending value 0.2. So this is the way we are going to form the triangles, right? Next we need to find out for us. So let us take, this is the one of the triangular, the starting value. Okay. So starting value 0. So this is 0.3. So this is for 0. Then you need to find out the time. So what is the time? This is the x-axis, this is for y-axis, right? So for a 0 magnitude, what is the time? Time also 0. Next, let us take for 0.3. For magnitude is 0.3, what is the time? Then you just go through the paper, switching frequency is given. So if the switching frequency is 2 kilohertz, let us take for 2 kilohertz, you can find out for the 2 kilohertz, find out for the time period. So now 50% of what is the time period, just you can enter here, that is the next value, time value. Next again return back to the next, return back to the triangle again 0.32, again next value 0. So the magnitude is 0, what is the maximum value of the switching time period, then you can enter. So you can, you just go through the paper, switching frequency is given or operating frequency of the switches is given, you can find out time. Let us take for the total time period maybe a 2 microsecond for example. So now you can divide by 2, 1 microsecond. Here you can give for 1 microsecond for magnitude of 0.3. 2 microsecond you can give for the total. So now move on to the MATLAB. So here the switching frequency given, just to go through the paper. In the paper itself, what is the switching frequency? They are already mentioned here. The carrier frequency value is 1 kilohertz. For 1 kilohertz, we can find out what is the value of the. So how do you find out the number of carrier is number of level minus 1. This is a general expression. So for any topology of multi-level inverter is based on the how many level of output voltage for inverter. So based on that, you can minus 1, you will get the number of carriers. So carrier means a triangular signal. This is for 7 level, so you have to minus for the 7 minus 1, you will get for a 6 carrier signals. So now move on to our MATLAB. Okay, so now go for a configuration. Just open for the new model. So click for the Simulink library browser, then go for a create new model. Just open the one window, then go for the source. Go for a source. In the source, you have a repeating sequence block. Okay, repeating a sequence block. So just take for the repeating sequence block. Okay, take for the repeating sequence block. So what is the time for 1 kilohertz? எவ்வளோ வருது? சொல்லுங்க பார்க்கலாம் எவ்வளோ வரும் அப்ராக்சிமேட்டில் 0.5 e power minus 4 கரெக்டா 5 e power minus 4 கரெக்டா 1 கிலோஹெர்ட்ஸ்க்கு 1 மில்லி செகண்டா okay, so let us start for the time value 0 output value is also 0, right? Next, first we are going to start for the triangular 0 to 0.3, then again 0.3 to 1, right? Now move on to here. Starting time is 0. Again output value is 0. Then time value 1 e power minus 3. So divided by 2. Okay, you have to take it as a 50% of total time period for next level. So now the magnitude of the output value of the first triangular is 0, 0.3, then again 0. So now 0.3, right? Next, again the total time 1 space 1 e power minus 3. So again the ending value of output value is 0. Okay, so now you just apply. Then we are going to convert for a ramp sequence into triangular signal, right? The same thing you can do it again, just copy. So now you just change for the second triangular, starting value 0.6. Starting value 0.6, right? 0.6. So now just go through here. The starting value is 0. Next value of triangular is 0.3. Next again return back to 0, right? Our total time period is this is the 0 to up to this is the total time period 1 e power minus 3, okay va 1 e power minus 3, right? This is the time for 0 to 1 triangular. This is the total time period. So the 50%, this is the magnitude 0.3. So what is the time for the magnitude of 0.3 is 1 divided by 2, 1 e power minus 3 divided by 2. So right, so this is the output values in the simulation. So the output value, just to go through the repeating sequence block, output values you have to mention the magnitude values 0, 0.3, again 0, right? Second triangle is start from the starting value is 0.3, next value 0.6, then again next value 0.3. Then third triangle the magnitude is starting value is 0.6, then another value is 0.9, again return back to 0.6. Now I am going to construct for the carrier signal. First value is 0, 1 e power minus 3 divided by 2, 50% of total time period. Then total time period is 1 e power minus 3. Then the starting value of the first triangle is 0, the time also 0. Next for 0.3, the corresponding time period is 50% of the total switching time period, 1 e power minus 3 divided by 2. The next value is 0 and total time period is 1 e power minus 3, right? Next, the same thing, just you can copy. So I just, please follow me. So you just remove the repeating sequence, show format, remove for the show block name. So let us take, this is the first one, okay? So the second one is just you change the magnitude, that's all. Don't change for the time period. Time period is fixed, right? So here 0.3 starting value, ending next value is 0.6, next value is 0.3. Okay, then again you just copy, again paste here. The starting value is 0.6, then again next value is 0.9, then another value is 0.6. Okay, this is a positive group. Next, we need a constant value. So to obtain for 0 level, so just take for the constant block. You can just mark for the inside of constant block 0. Same thing you can just copy, paste. Same thing you can just copy and paste, right? Then next you do for a minus, you just change the signs only. minus 0.3, 0, minus 0.3, then again just change for minus 0.3, again minus 0.6, then again minus 0.3, then again you can go here, again just change for here minus 0.6, so just change for minus 0.9, then again 0.6, right? So now this is the first process, first step. So now we are going to, so this is the way we are going to form the carrier signal, C1, C2, C3, 0, then C4 and C5 and C6, right? You can take for the reference signal, that is M is called as a reference signal. You can go for the MATLAB, then again go to the Simulink library browser. In the Simulink library, source is there, okay? Just in the basic Simulink, source is available. In the source, you just move on to the cursor, and then again the sine waveform is there. This sine is act as a reference signal, right? So now in the reference signal, you change the amplitude is a modulation index. You can change for modulation index 0.8. Again, here you have to give for the supply frequency, right? 2 pi f, that is radian per second, 2 into multiplication star, pi value small letter p and I into 50. So 2 pi f, you can, here you have to enter for the fundamental frequency value, right? Operating frequency we are going to enter into the carrier signal. So carrier frequency is always a fixed, right? You don't change for the magnitude of the carrier frequency. Now we can go for the mux block. You just go for a mux, otherwise you just type mux and search. So many input and single output. So let us take for, I want to see all the 6 carrier signal in the single scope, right? Or I want to see the 6 carrier signal and reference signal. So let us take for the 7. Number of input is 7, right? So just click here, and also you can track the, just track. Just extend the line. Okay, start from the first one, triangular 1, triangular 2, so triangular 3. You have to check whether the triangular is properly generated or not. Next again, 4th carrier signal, and again next one, so again next one, then finally our reference signal. So this is our reference signal, okay? Next you can go for the scope, go to the sync, take the scope, paste here, and then double click and go to the parameter. So in the parameter, go to history, and then first you have to remove the limit data point, then apply, okay? Then next you just connect like this. So again you can go for the simulation. So take for the power guy or power GUI, power guy. So take for the power guy and paste here, right? So next to go for the simulation, then go for a model configuration parameter, click here, then change the solver, OD23dB solver, then start from the, let us take for a point, for example 0.5, let us take for 0.05. Okay, 0.05. So apply. Now run the simulation. Now you can see the waveform, the triangular is not properly generated. Now the triangular is not properly generated. Why? Any idea? Most of them knows about MATLAB. But here we are given all the values, but the triangular is not properly generated. Okay, right. Now, so whenever we are going to use for the triangular signal, go to the model configuration parameter. Here you can apply for the maximum step size, 1 e power minus 7. Next again 1 e power minus 7 based on the our switching frequency. So again initial step size, now apply, now you can generate. Now see here your triangular is properly generating now, right? So this is the main difference. So now see here, so now we are generating our triangular, your reference signal and a triangular signal. Okay, so you have to enter the maximum step size and initial step size 1 e power minus 7. That value, how we are going to enter that value is based on your switching time period value. Okay, you have to give the below the your switching time period values, right? So this is the, so whatever the so this is the first one, right? So whatever the waveform here, the same waveform we are constructed in the MATLAB, right? You have a sine waveform and you have a carrier waveform. So can you do it, everyone, can you do it? Okay, if you have any doubt please ask me. Do it நீங்க பண்ணலாம்ல உங்களால. ஓகே பண்ணுங்க பார்க்கலாம், இதை முத முடிங்க. ஓகே.